Welcome to clickmyproject.com. Let's discuss on the paper optimization of ECG classification by means of feature selection. In this paper, we are going to mainly concentrate on the improvement of classifier performance by the introduction of the feature selection. Feature selection is nothing but selecting the best features from the extracted overall features. Say for example, if X is the original set, it is having totally n features, and j of xk is nothing but the evaluation measure that should be maximized, and we are going to generate the subset of features that is having the size, that means k number of features, which should be less than the total number of features n. This is the main criteria we are going to concentrate in this paper, and we may take three kinds of ECG signals such as normal, epileptic and heart failure. After filtering these three kinds of signals, next we are going to extract them temporal or morphological. Sometimes the statistical features may also be extracted. The extracted features are named as feature vector. With the help of this feature vector, we are able to classify it, but sometimes it will lead to some misclassification. To avoid this problem, we introduce a feature selection stage between the feature extraction and classification stage. By introducing so, we can improve the classifier performance and we can achieve the high accuracy. Here we are going to introduce the sequential floating forward feature selection method. The feature selection will result a subset of size, the number of features k, which should be less than the total number of features n. So later onwards, we will describe the method of selecting the subset of features from the main set. Now let's see the explanation of this data flow diagram. The first thing is we have to load the ECG signal. Afterwards, the input ECG signal should be filtered. The aim of this filtration is to remove the unwanted noise present in the input ECG signal. The next thing is decomposition. Decomposition is by means of wavelet filter. At the end of this decomposition, we are having the coefficients, 4 different coefficients: approximation, detail, horizontal and the diagonal coefficients. Followed this decomposition, the next one is feature vector computation. Feature vector is nothing but arranging the extracted features in the form of 1 cross n vector size. N is the total number of features extracted from the previous stage. The features computed are nothing but statistical measures such as mean, standard deviation, like that. The next thing is subset selection. All the extracted features are not at all going to input for the classifier stage. If by doing so, we can get some misclassification results. To overcome this, we introduce a feature subset selection in between the feature extraction and classifier stage. The algorithm here we are going to introduce a sequential forward floating search mechanism for the selection of subset. So the selected features, it should be of length k, and this k is less than the total number of features extracted. Come to the next block. This is SPM classifier. SPM is a binary classifier and it will be introduced here for classifying the input ECG signal as normal or abnormal. Under the abnormal category, again it is classified as whether it is epileptic person or heart failure person. So these three kinds of classification results will be predicted at the end of this SPM classifier stage. Now let's see the execution of our proposed system. The main file is ECG main.m. Select this file and then choose the option run file. A GUI window will be shown to you and is having the menu bar options also. Under the file option, select open. File dialog window will be shown to you for the selection of testing signal. I'm going to select the fifth one. The signal will be loaded and it is also displayed in this access control Correspondingly, the PSNR and MSc measures will be displayed in the text boxes. Now I am doing the filter now. Under pre-processing, select filter. The filtered ECG signal will be displayed. Now you can see the difference between the input noisy ECG signal and the filtered ECG signal. Now see the PSNR value. Now it is 64.4505. It is much better than that of the original PSNR computed for the input ECG signal. And the mean square error, it is also reduced. Next thing is under feature extraction, press show feature. Features will be extracted. Meanwhile, it is displayed in separate figure windows. Now this is the first one that will show the baseline drift elimination, and afterwards the detected heartbeat rate. Now it is displayed here. Heartbeat rate is now it is 35. Now the second one is wavelet features. The wavelet coefficient values, it will be listed here. Third one is statistical features. The features are nothing but computation of minimum, maximum, mean, standard deviation, minimum maximum difference of the computed wavelet coefficients from the decomposition stage. Now the feature extraction stage is over. Next stage is selection of best features from the extracted one. Feature selection completed. Now see the difference between the feature set size before selection and after selection. Now this is before selection. The total number of features is equal to 35. That means 1 cross 35 vector size. Now after feature selection, now the size is reduced to 2. The selected features are only 2. Next we are going to classify the input ECG signal. Select this option SPM under classifier. Now it is predicted as normal. This ECG signal is taken from the normal patient only. Now we are going to see the performance analysis by pressing this option. Now see this tabular column. The classifier performance measures will be listed out here. That is correction rate, error rate, sensitivity, specificity. These are all the main classifier performance measures. And this one will be the confusion matrix. How far our classification will yield the best performance. That means how the normal category is correctly classified as normal. The diagonal elements, it will show the correct classification. Other than diagonal, it will show the misclassification. Now we can see the bar chart representation also. This is the 3D bar chart representation for the equivalent confusion matrix. And the last one is the correct and incorrect classification results for each and every category. Normal, partial epileptic, and then heart failure. By seeing these results, we can say our system will yield the best performance when compared to the existing systems. Thank you.